In this session, we are going to discuss differentiation for unilateral Laplace transform property or differentiation in time domain. So this property states that if a continuous time signal x of t, then its Laplace transform will be x of s, and if time derivative of this x of t signal Laplace transform will be s into x of s minus x of 0. Now we try to understand the proof for this statement. So we start the proof with the basic definition of Laplace transform. It says that Laplace transform of x of t for unilateral case is 0 to infinity x of t e power minus st dt. So now we need the Laplace transform for time derivative of x of t. So we take the time derivative for this signal x of t. So d by dt x of t equals to, it becomes 0 to infinity time derivative of x of t e power minus st dt. So now rearrange the right side expression as, so integral 0 to infinity. So we write e power minus st here and the time derivative of x of t signal as the second, right, dt. Now observe this expression. So this e power minus st is one signal and derivative of this x of t is the second signal. So it is look like a basic form integral of u dv. So this can be expressed as u v minus of integral of v dv. So here we know that u in this case, in our present case, so e of st is the u and this is v. So derivative of v. So we write it as u is equal to e power minus st and v is equal to x of t. And we express in a similar way as u of t. U is e power minus st and v is x of t minus, so integral of v, that is x of t, and derivative of e power minus st. Derivative of e power minus st. So e power minus st derivative is e power minus st into minus s. Okay. So that we can write it as integral of x of t minus s e power minus st. Now we use the same expression, so for further simplification of the present expression. Okay. So now we'll substitute here. So that equals to e power minus st x of t limits 0 to infinity minus of integral over 0 to infinity x of t minus s e power minus st into dt. So that equals to, so now apply the limits to the first case. So upper limit is infinity. So when we substitute this infinity, so e power minus infinity, right, into x of infinity. So this e power minus infinity is 0 into something, so that is 0 minus of lower limit is 0. E power minus t, it becomes e power 0, 1. 1 into x of 0 is 0, right? So that is 0 minus x of 0. So in the second case, so observe the minus s is there. So we shift this s to the outside because it becomes a constant here. Minus into minus plus, s is outside, and integral over 0 to infinity x of t e power minus st dt. So now this is minus x of 0 plus s into, and this function gives the Laplace transform of x of t, so that we can write it as x of s. So this is equals to s into x of s minus x of 0. So this is nothing but the Laplace transform of time derivative of signal x of t. Right? So this is what the statement for this particular theorem.